In Haskell, we have already seen some higher order functions, and they allow us to abstract away a common pattern in our computation. So for example, map lets us abstract away the common pattern of transforming lists from one type to another type. Filter allowed us to abstract away filtering lists, as you would expect. Now we're going to have a look at something else which is a little bit more advanced, but it allows us to do something similar. It allows us to abstract away a common pattern of recursion. So let's have a look at these functions. You'll notice I've selected these functions because they're all extremely similar. They all work on a list and they all do something to the list at each stage. So they take out an element and they do something with it. So before we get into that in too much detail though, let's remember that a list is really syntactic sugar for something that is x1, cons, x2, cons, x3, all the way up to xn, which is then consed onto the empty list. So it's important to remember that this is the structure of the list. Now, if you combine that with looking at these recursion schemes, you'll see that what we do is we take an x out, we replace the cons with some sort of function, and then we recurse. So really what we're doing is replacing the cons operator with some sort of function. Here it's 1 plus, here it's times, here it's plus, and the empty list, we're replacing that with a value. That's our base case value. So here it's 0, here it's being replaced with 1, and here it's being replaced with 0. So these are all doing the same thing. They're all taking the cons operator out and applying something else in its stead. Then they replace the empty list with a value. Now, there is a higher order function called Foldr which will do this for us. It abstracts away this recursion scheme and allows us to automate that process. So, what does Foldr do? Well, Foldr, let's have a look at its type. So Foldr is part of the foldable type class, so it needs something of type T. We'll worry about that later. It takes a function from A to B to B, so that's a function that takes something of type A and something of type B and returns something of type B. It takes a value of type B, it takes something of the shape of a list and returns a value of B. So, first things first, this function, which is from A to B, that's to give us more flexibility in how we work with types. Now A and B could be the same type, they could be both integers, whatever that happens to be. They can be the same type. This is just to give us more generality with this fold function. And you'll notice that the value that it takes, this is the accumulator, this is what we replace the empty list with, is of type B. So this function has to return something of type B because the accumulator will eventually become the value that we return to the user. Now this T of A is something we'll get onto in a couple of weeks or a week or so, but you can just think of this as a list of type A for the moment. So what does Foldr do? Well, Foldr for some function $, for an accumulator value and for some list x's of this shape here, just replaces the cons operator with the function to every value up until it gets to the empty list, which it replaces with the accumulator value. So it's this type of recursion, it just automates that away for us. So let's say I want to do, we'll do length list last, but if I want to do product list and I want to do 1 to 5. On a side note, this should be the same as the factorial of 5. So we get 120. Now I can equivalently do this with Foldr. Now what I give this is the times, because that's what this is placing in place of the cons operator. And the value for the base case is the same one that I give the accumulator, and I give this the list 1 to 5. Voila, I've done the same thing. So this is what Foldr does. It replaces this recursion scheme just by a built-in function so that every time you don't have to write out this function. It would get very tedious if you had to do this every time you built up a Haskell class. So that's what Foldr does. It gets rid of that tediousness for us. Now similarly, we could do sum list. So let's say we want to sum the list of 1 to 5. Gives us 121. So let's remember that. Oh no, actually it shouldn't give us 121. That's a product list. So that should be sum list in there. Let's save that and reload. And let's call sum list again to get over that. So that should be 15. 121 is a wee bit big for that. So sum list should do that. Now of course we can use Foldr here. So we can replace this with, we're using the plus operator. That's what's happening in here. And we're replacing the base case value, or the empty list with 0. Give this 1 to 5. Hit enter. And we have 50. So now we can replace these two functions here with a one-line definition using a built-in function in Haskell, which makes our lives a lot easier. You could, of course, if you want, rename these functions up here using Foldr. That would be totally fine. But let's have a look at something else. this a little bit trickier. Now, you might not think the length of a list would be a little bit trickier, but it's just slightly, because if you think about what's happening with the type of Foldr, the value from the list is the first argument, and the accumulator is the second argument. So we have to add 1 for each element of A, but we don't really care about what A is. It was a little bit easier in these ones because we can just add A to the accumulator and so on and so forth. However, in this case, we have to think a little bit more. So what I'm going to say we do to replace length of list, so we'll do Foldr, and we'll leave that for the moment. Of course, our accumulator should be 0 because we want to emulate the length of list base case. And we'll give it the list 1 to 5, which should have 5 elements in it. So what do we put in here? Well, what I'm going to propose we do is to manipulate the input here, we replace this with a lambda function. So I'm going to say x in ACK goes to ACK plus 1. And this is essentially saying just use the accumulator as a counter, add 1 to accumulator every time you get a value of x. So if I hit enter, we get our value of 5 out. Of course, if I change this to 50, get 50 out. So as you can see here, we're really just replacing harder to write functions, or more onerous to write functions, with something much more concise. So Foldr gets rid of one type of recursion for us. We'll have a look at different folds later on, but today I just want you to understand that this is replacing this common scheme for us. Now, of course, if you want some proof that I've set up here, we're just replacing these cons operators with a function. So if you want proof of that, what we can do is Foldr, we can give this the cons operator, and we can give it the empty list as the base case, because that's what's at the end of a list, and we can give it 1 to 5. And this will return 1, 2, 3, 4, 5, because this is the identity function. This doesn't actually change the list. Because what Foldr does is replaces the cons operator in a list with another function. So if we give it the cons operator again, it's going to be the same list, and it replaces the empty list with a value. So if we give it the empty list, then it's absolutely fine. So you can see in Foldr, these could also be list values here. So this is a very powerful function to understand. It can get rid of a lot of heavy lifting for you, but really what you want to think of Foldr is a function which replaces this common recursion scheme for you with a very simple and lightweight definition, and it just folds a list down into one summary value. Now that could be the product, it could be the length, it could be the sum list, it could be something much, much more complex than you expect. Now, one thing that you should be aware of is that this might not give you the answer you always expect, because if you think about what's happening here, we can't evaluate Foldr necessarily, there are some edge cases we'll get onto, until we get down to this base case. So if I give you something like Foldr minus, and let's say 54, and I give you 10 and 11 as values. Now, you might expect that I should just be subtracting 10 and then 11 from this, but actually because of the precedence and the way this works, you get something a little bit different. So you get 53 out, which is because you have to get down to that final case, which is 54 minus 11, and you take 11 minus 54. So you take 54 away from 11, you get a negative value, and then you take that value away from 10. So this is going back up the way. So you need to be wary about when you use this, and just think through the steps that are going to happen when you execute this. So I think that's everything for today. We'll be getting more experience with Foldr while we're having a look at Foldl as well. But that's everything for today. If you have any questions about this, please do let me know. Thanks.